Welcome back to Ferho's website. My name is Masoud. I'm a physics teacher. I'm gonna solve practice 1H, page 20 for you. This practice includes two questions, two problems. Let me read the first one for you. A girl sits in a tire that is attached to an overhanging tree limb by a rope 2.1 meters. So this 2.1 meter becomes a radius of circular track. A child or a girl sits in a tire, and the tire is tied with a rope, and the rope hangs from a tree branch, from a tree limb, right? So in this situation, length of the rope becomes radius of a circular track. The girl's father pushes her with a tangential speed of 2.5 meters per second. This one is Vt. If the magnitude of the force that maintains circular motion, her circular motion, what's the meaning of this? The force that maintains circular motion, simply we can say this is Fc. What's the girl's mass? So we look for mass of the girl, right? Just write the question, just write the equation. Where does this rule come from? Maybe you say, teacher, where does this rule come from? It comes from the main rule of the centripetal force. Fc is equal to m Vt squared over r. Just rearrange the equation for m and to get this form. Is there any, let's say, do we need any conversion here? No, because units are unified. Units are valid in SI. We have meters, second, and Newton. That's why just substitute the values and find the answer. So m is equal to, r is equal to 2.1 multiplied by Fc, 88 Newton, divided by Vt, 2.5 squared, and find the answer, which is 29.7 kilograms. This is the mass of a child. Right. Let's move on to another question. The next question and the last question for this practice. A 905 kilogram test car travels around a 3.25 kilometers circular track. It's a, let's say, challenging question, right? I love this question because units are not unified, and we have one more information which did not actually confront with it in previous lessons. We haven't encountered this information actually in previous questions. That's why I'm talking about this one. I'm talking about this information, 3.25 kilometers circular track. If the magnitude of the force that maintains the car's circular motion is 2,140 Newton. So this is Fc. This one is, till now I don't reveal the answer. I'm not gonna reveal it for you. What's this? This is mass, right? It says, what's the car's tangential speed? So we look for Vt. Let me read the question again for you to guess what this information is. It says a 905 kilogram test car travels around a circular track. There's a car travels around like this. Let me draw it here. There's a square, right? There's a square, and the car circles the square. It travels around, right? It circles around the square. What's where it circles around the square? It moves around the square, means, and it finishes its path. It returns to its original position. What does it mean? So this, whenever the moving object reaches its original position means it travels a full circle, right? It travels one revolution. And in other words, I can say it travels a, let's say, circumference of the circle. Either you can say circumference, no problem, or you can say, teacher, the car travels a, let's say, travels a one full circle, right? Or you can say it travels a distance across a circumference of a circle, right? So I want you to guess the rule of circumference of a circle. What's the circumference of a circle? Circumference of a circle is found by this equation. C is equal to 2 pi r, right? But we don't need the circumference of the circle, actually. We need the radius of a circle. We need the radius because in centripetal, let's say, force, we don't deal with circumference, we deal with radius. That's why whenever you divide the circumference of a circle by 2 pi, you can find the radius directly, right? That's why this information is circumference. C capital means circumference of a circle, and circumference means the distance, let's say, across the, it's the full, let's say, when the object travels the whole, let's say, the whole distance across a circular path. The object, the moving object, travels a whole distance across a circular track, so it travels a circumference. We get the circumference of a circle. So C is equal to 2 pi r. And we have one more note. The distance or circumference is given in kilometers. How do you convert it to meters? Just multiply it by 1,000, multiplied by 10 to the power 3, and to find the answer. So the first step is to convert the kilometer to meter by multiplying by 10 to the 3. So except for this conversion, other units are unified. I want you to, let's say, find the radius of a circle by dividing the circumference, right, by 2 pi. 3.25 times 10 to the power 3 divided by 2 pi. Approximately, the radius becomes 517 meters. Right now, the information are available. Everything is ready for finding the VT. I want you to, let's say, focus on the rules and reinforce your mathematics, actually, because mathematics is the language of physics. And whenever you want to, for example, write the rule for any variable in physics, you have to use the cross multiplying. You have to know information about the mathematics, actually. That's why whenever you're good at mathematics, you will be good at physics, because physics and mathematics have to do with one another, right? They are interconnected to one another. You cannot, let's say, remove mathematics from physics at all, right? So VT is equal to radical RFC divided by M. After we found the radius, right? After we found the radius, right now I write the rule for VT. VT is equal to radical RFC divided by M. VT is equal to radical R. We found the R already, 517, multiplied by FC. We have FC, 2,140, divided by mass of the actual test car is 905. And after that, you can find the answer, which is 35 meters per second. That's it, guys, for today. I appreciate you for watching this video, and bye-bye.